Hello all, this is open source repository named Dataset Generator, where this is generating dataset for fine tuning LLM models. Uh, Basically, like if we have very unstructured data like PPT, PDF, uh, Google Docs, or text or images, whatever we have as unstructured data, we can pass it to this library, and then it makes us a structured question answer, so that that question answer can be used for fine tuning LLMs. Basically, if we see an overview of this, right? Um, First, the user gives the input data. Input data may be like PDF, PPT, any kind of unstructured data. Then that will be first passed to a text extractor, which will extract all the things into a single format of text. If you have it as text documents itself, it is well and good. Next is each and every text is chunked based on the token limit of each and every LLM model, so that each and every chunk is passed with a system prompt to the LLM model, you can use like Azure OpenAI or API key, or Azure Open API, or any custom model like whatever you have. LLM, if you have VLLM self-hosted, that is also well and good. If you have Olama, that is also well and good. The uniqueness of this project would be like if you use an very small model like in Olama with quantized model, right? That could also be able to generate a structured, consistently structured output. So that's a good part over here. Everything will be saved as a JSON-L format. Every question consists of a question and answer pair will be in a JSON-L. So that JSON-L will be now passed to another function, which will iterate to each and every question, and from the each and every folder, which will be passing each and every question answer to a vector database. That vector database will be taking care, is this question repeated, is this question more similar. It will checks, and if it is more similar to another question already present, then it will remove the one duplicate questions. That's the overall idea. Why are we doing this is, right, if you are trying to generate a data set for your website, you would have scrapped the website and converted into PDF, and that will be converted into text. So the header footer will be same. So if the header footer are always consistent, if you try to generate the question from that header footer, all header footer questions will be more similar. So I think that's not a good valid thing. Here the similarity score I have given 0.2, but currently I'm using a 0.1. You can customize that in the config file also. If you see the config files, right, that consist of how are you using the model, Azure or OpenAI or self-hosted, what is the model are you using, what is the max token limit for the model, what is the input folder path, where should you save the path, what is the vector DB path you want to give, what is the collection name for the vector DB you want to give, what is the duplicate threshold you need to give. Everything is customizable over here, and the code is also so simple over here. We could see the demo so that you could get a still more clear understanding actually. If you see this code, right, this is the main.py. If you clone the repository by giving like git clone and giving this path like git clone https, you'll get this folder structure, actually the whole library path. Now you need to give the example.env. If you have API URL and API key, you will give it for OpenAI, or if you have self-hosted models with the OpenAI library as an exposing OpenAI API compatible libraries, right? Then it is well and good to give only API URL and the API key. If you have Azure, you can just integrate it over here itself. Next, if you come to the picture here, right, here we have an input data. If you see over here, we have PPT document, you have PDF, text files, txt, file.txt, everything is here. So if we start, we will just start over here, like let's give clear, and if you want to write just python main.py. I have also mentioned over the what are all required libraries to run this library also. If you give, if you create a virtual environment and start installing from the requirement.txt, that's it. All are well and enough. Now, if you see here, right, I am just giving python main.py. Basically, you can see here the folder ChromaDB is deleted successfully, because I had a ChromaDB folder which is already present. So there should not be any duplication within the vector space. So that only I did it. two things have been skipped over here. One is file text.txt, and the next one is extending.txt. So txt files are removed, and if you see here, right, the ppt is converted into txt, and everything will be converted into txt format. Once that is done, then we start with the generation questions.txt. So each and every file from here we will generate a Q&A pair. That Q&A pair will be started saving here. File.jsnl, it is saved here. If you see the file, this is the content in the file.txt. This is the question generated from that document. So building apps will be loaded. Next, python txt is also here, so that as per the context length it depends, and it tries to generate the question answer pairs actually. And if we see here, right, everything will be started generating. I think the last one file is getting generated, I guess. That is this extending.txt file is getting generated. I think let's wait for this. Once everything is generated over here, we will get everything as a JSON-L file with a structured format. We can access this, and we can see here question answer pair is over generated. Currently you can see that also, like I'm using Olama only, the Llama 3.1 with 8096 as the highest token limit over here, and the duplicate threshold is 0.01. Llama quantized model is very small model. We can run it through any of laptops or PC. Even Olama supports the CPU version also. We can use Olama for this, or any other things as we can see over here. Once this is done, right, here is the system prompt what I have given. Like basically giving out a structured what is its responsibility, rules and responsibilities over here, and giving a few short example to follow it more carefully. And I'm also asking it to read it all the above and answer more carefully. So once this is done, right, I have split it into each and everything as a separate modules. Like first, if you are trying to use VLLM as an inference engine, right, I think the last one is also ready. Inference engine here, multiprocessing also supported, so that you can process the file very quick. If you are using Olama or any other things, then sequentially it happens more sequentially, so it may get delayed. I recommend you to use any APIs, or use if you are doing self hosting, then try to use VLLM. Once that is there, we are just passing the file to process file. First of all it will try to clean all the document, extract the document, everything is after txt. Then it will try to generate QA, basically pass the text. The text will the generate QA will be taking care of chunking the parts. If the token limit is higher, then it will pass a chunk. Then it will pass it to the LLM, generate questions, combine all the chunked questions together, and save it as a one file. So the input file name with the same name will be the output file name also. Once that is done, then the JSON cleaner comes into the picture, where unwanted JSON lines will be removed. If the JSON line doesn't be structured format, or it doesn't have it only has question and doesn't have any answer, right, everything will be changed over there, and JSON cleaner will take care of making everything structured. And the last one is the file processing. The file processing will be taking care of removing the similar questions. Everything will be done over there. We can see ChromaDB has been created, and everything is done over there. This is the overall picture. I think you could understand from the diagram itself, I guess. If you want to see the last one, embedding.json, this is also generated. So everything is generated over here. Based on this, if you have any queries, please try to raise, or if you have issues, please put it on the GitHub, or if you want to develop still more, you can take a fork and create in a pull request. That's it for this video. If you have any questions, let me know. Thank you so much.